So we get to the part of the chapter where we talk about these leftovers of our solar system affecting us here today, or affecting Earth, basically. Asteroids colliding into Earth, comets colliding into Earth. In fact, we talked about how they believe that most of the water on Earth came from comets that impacted Earth early on. Remember that our solar system used to be pretty darn chaotic compared to what it is now. And along those lines, we do believe that the dinosaurs that were prevalent here historically on Earth were wiped out. The beginning of their end actually came as the consequence of an asteroid hitting the Earth. And I'm going to kind of talk you through it, but basically that event was about 65 million years ago. And again, I'm going to kind of talk you through that. But among other evidence is this: the fact that there's an element called iridium, and iridium is relatively rare on Earth. You don't really see it in Earth's crust much. But this father-son team, which I think is so cool, I think it was the father was the physicist and the son was the geologist, actually studied the layers of rocks and found a layer. You know how rocks, the oldest, how do I say this? To look at the history of Earth, you can go down rocks, layers of rocks. And so they came upon a layer of iridium that was basically on top of the last dinosaurs. Okay, and so it's looking then like you have dinosaurs living and dying and living and dying, dinosaurs living and dying, living and dying. Then you have an iridium layer, and then you have no more dinosaurs. Okay, so this actually is looking at kind of layers of rock. So we have dinosaurs down here, a layer of rock that contains iridium, and no dinosaurs here. And I don't know if it's on my previous slide or the slide coming up, but the catch is that the element iridium is, as I think I said, kind of rare on Earth, but we find iridium, that element, in space rocks, okay, in meteoroids, or meteorites, I guess I should say. Okay, so what size are we talking about? The meteorite, the rock that needed to have hit the Earth, must have been about 5 miles in diameter. And then what that did was to send up a lot of debris in the Earth's atmosphere. And the debris in the Earth's atmosphere hung there and hung there and hung there. And so while it was hanging there, it blocked out the sun, the light from the sun. And as it blocked out the light from the sun, then the plants that needed the sunlight died off. And without the plants, your dinosaurs that ate the plants, then they died off. And then your carnivores, the dinosaurs that ate the dinosaurs, they died off too. Okay, so I've got, I will make available on the course website this video through video on demand, so you can kind of watch what I'm talking about. But if you wonder, you know, these days, are we going to have how do I say this, meteorite hitting the Earth? What sort of consequences could it have? You look back at the extinction of the dinosaurs, where they actually even have maybe a likely impact site here off of the Yucatan Peninsula, off of Mexico. So things are consistent with that being the site of impact. 65 million years ago. Isn't that cool? Well, it depends on if you're a dinosaur or not. Well, a little closer to time, in our own time, I believe is 1901. What you're looking at, well, I guess I'll come back to it, but that in 1901, there was something called the Tunguska event, and we believe that was maybe a comet that exploded in the Earth's atmosphere. But asteroids and comets, they have hit the Earth in the past, and they will continue to hit the Earth. Now, again, it's not as chaotic as it was early on in the formation of our solar system, but we definitely still have those leftovers straying around. Remember, I showed you NASA's Near-Earth Object website, where we can track these objects and the size of them. And there's all sorts of movies out there to talk about, can we redirect these asteroids or comets as they're headed our way? Okay, so not the question is if a major impact will occur, but when. And I'll kind of give you some timing ideas here in a minute. Major impacts are rare. The types that caused the extinction of the dinosaurs, we're talking millions of years, but the last one was 65 million years ago. Okay. If a slightly less dramatic event could be tens to hundreds of years. Okay, so will have a link on the website for this event too. Actually, this Tunguska event, as it's known, back in 1908, excuse me, not 1901, but 1908. I also have this as part of the playlist for Chapter 9, a video. But the thing about that time in Earth's history was that was gearing up for the First World War, I want to say, and kind of politics got in the way of kind of really hashing out what happened. So this event happened in Siberia. And what you're looking at, those downed trees, it's a photograph of basically, just miles and miles of trees that were downed like that. And so, like the slide says, about a 40-meter object blew up in the Earth's atmosphere. Okay, this is another sign of an impact. I think we looked at this earlier, where here's a crater on Earth that has survived some 50,000 years. It's a relatively recent crater in Winslow, Arizona. So the point is, yes, the Earth has gotten hit. So the Earth is getting hit all the time. I can't remember the number, but it's like the Earth increases in mass by like a ton a day just because of micrometeorites basically landing on it and increasing its mass. Isn't that cool? But you can see that the more devastating the impact, the less likely it happens, basically. So is there an asteroid out there with the Earth's name on it? Well, maybe. We don't know of it yet. This is hopeful that, doing things like deep impact, where we actually interacted with the comet, we're gathering information on how to maybe deflect these things. So, like this says, it's problematic to take a big asteroid and hope to break it up into smaller asteroids. Okay, how much advance warning will we get? And actually, how much advance warning will we get? That's kind of what this little documentary talks about. There is an asteroid called Apophis, and this documentary, or this segment of this documentary, I have posted as part of my Chapter 9 playlist. And Apophis is, we know that, I can't remember what year it is, I think 2036 or something like that. But Apophis is going to come close to the Earth, and if it hits the sweet spot called a keyhole or something like that, then years later it will come back and it will hit the Earth. So I don't know. So actually, it's thought that the presence of the large Jovian planets, perhaps even Jupiter, was instrumental in deflecting some of the comets that we might have gotten from the Kuiper Belt early on in the chaos of the, or even now, I guess. It helps protect Earth. So impacts can extinguish life, okay, but perhaps impacts were necessary for life. So, that pretty blue marble we live on has been a delicate balance for all along. And